As Manibat should describe you about disk management, now let's start on swap space management. In swap space management, it is used when RAM get full of processes and every process wants CPU to perform execution. In result of the multiple processes in the memory, a lot of processes in the main memory congestion occur. That congestion cause damage to our system. To prevent system from damaging and to make it secure, we use swap space. Before start discussion, let's consider the two terms swapping and swap space. Swapping is the movement of whole data from main memory into the virtual memory, while swap space is the portion. It is placed on the virtual memory and that virtual memory resides on the hard disk. Next are the uses of the swap space. Swap space used for two purposes. First one is to create the place for low priority files or low priority process. Second use is to create some free physical memory. To create some free physical memory to prevent system from crash. Next, what is the importance of swap space? Swap space is basically used to allow to store all data that couldn't stored into the main memory. Swap space use. There are two terms used in the swap space. First one is swapping, means moving a whole process including its code data segment from main memory into the virtual memory, while paging is the process. Paging is a technique of creating pages or creating chunks when a program is divided into the multiple processes and all higher priority processes move into the main memory in RAM while low priority processes move into the virtual memory. Swap space location. There are two places where a swap space could reside. First one, carved out of a normal file system, means it could reside into the file explorer, etc. Second one, on a separate disk. When partitioning done on a disk, each disk have its own swap space. Diagrammatically, let's consider if we have no virtual memory, then what happens? There are multiple processes into the main memory, access given to the some limited processes. Here is four process get access into the main memory. Access to fifth one process is denied. Fifth one process couldn't use memory until or unless previous one get exit. When we are using virtual memory, mean extended version of the main memory, then we are supposed to be allocate all those processes from CPU into the virtual memory, and where we have no chance of congestion over here. There are more examples of all those processes that are using swap space, including Solaris, Unix. Here we consider Linux. Solaris, Unix, and Linux all are similar in using swap space management. There is a slight difference in each. In Unix, it is simply use swap space management. Next one, Solaris, there is a little difference that it use a double space of swap space, means some more extra space or swap space, while Linux is use it use a double space of the swap space and use the swap map, which means it's keep the track of all those processes that reside into the swap space. How a swap map can track the processes that reside into the swap space? It use swap map use a counter value. Whenever a counter value equal to 0 means there is a no process in the swap space, and whenever counter value greater than 0 it means there are some process into the swap space. Let's see over here. When swap map counter value 1 mean one process reside into the swap space. When counter value 0 means no process into the swap space. When counter value is equal to 3 means three processes reside in that swap space, and so on. Now disk management is done when a disk is divided into the multiple disks while swap space management is done whenever we have required some extended version when our system required to perform some another function and it have limited resources, so we create some extended version of our memory. Thank you so much.